Hi guys, so today we'll be solving this problem called neighboring bitwise XOR. Let's read the problem. A zero-indexed array derived with length n is derived by computing the bitwise XOR of adjacent values in a binary array original of length n, specifically for each index I in the range 0 to n minus 1. If I equal to n minus 1, then derived of I equal to original of I into original of 0, otherwise derived of I equal to original of I into original of I plus 1. Okay. Given an array derived, your task is to determine whether there exists a valid binary array original that could be formed, that could have formed derived. Return true if such an array exists or false otherwise. A binary array is an array containing only zeros and ones. Right. So we've been given a derived array and we need to return that if we can form an original array. What is original array? Original array is something which applies the formula of basically derived of I equal to original of I into original of I plus 1. Basically, original of I is original array basically should satisfy the formula and it would result into derived of I. And yeah, basically that's the idea. So let's try to understand with the first example. So derived array is basically 1, 1, 0, right? And we've written true that a valid original array does exist, right? So in order to understand this a bit, better, let's see what's a truth table. Truth table for XOR, right? So when we have one, um, so one, 1, 0, 0, 1, 0, 1, 0, right? So when we say 1, 1, 0, 0, so whenever there is a same element, we get uh, XOR value as the same. So 1 as 0, sorry. When it's the same element, we get the XOR value as 0. When it's different element, we get the value as 1. 1 XOR with 0 is 1, right? This we get the same element, right? So this is the truth table. So for this, it says that there does exist a original array which has all these values. So let's actually see it. Um, if we say that original array is like 0, 1, 0, so can we form a derived array? So the formula is like for derived is that original of I into original of I plus 1. That should give you the derived of I, right? Right? That should give you the derived of I. So let's see. So 0, 1, 2. So let's say on index I, 0 of derived of I, we have what is original of I, which is 0, and what is original of I plus 1, which is 1. So 0 XORed with 1 will give you 1, right? So yeah, great. That satisfies. Uh, then at index 1, we have everything from original of I, which is original of 1 is 1, XORed with I plus 1, which is 0. So which is here 1. Okay. Then we have the last index. So last index basically, yeah, original of I plus 1 or n, it can be 0, right? So zeroth index, like we need to consider this a cyclic. So if you're picking the last index, so 0 XORed with the first index. So which is 0 itself. So this gives me the derived array, right? So derived array is 1, 0, 1, 1, 0, and that gives me the derived array, right? So that is the process. Basically, we need to see if that original array does exist such that it forms a derived array. Then we need to return true. If not, then we need to return false. So just want to tell you that XOR as an operation is commutative, which means that the order does not matter and it's of no significance. So 0 XORed with 1 is equal to 1 XORed with 0 is the same thing. So 1 XORed with 0 is the same thing as 0 XORed with 1, right? So yeah, the order does not matter, right? So which means that, and also like we know that if same value is XORed, we get 0 value, right? So in this, if you see original of I and I plus 1, right? So this is I plus 1, and then this is I plus 1, and this is I plus 2, this is I plus 2, and this is I plus 3, right? If that exists, right? So, or it can be uh, I itself, right? So if you see, if you want to get a derived array, we are actually considering all the elements, right? So all the elements are occurring twice, right? Which means that if you're using an entire original array and we are XORing, then yeah, basically the elements occur I plus one two times, right? So which means that the entire value or entire array, if it is XORed, so if it's the same value, so 1 and 1, right? So 1 XORed with 1 will give you 0. Similarly, 0 XORed with 0 will give you 0. And 0 XORed with 0 will give you 0, right? So if the entire array is XORed, and if we get a 0 value, then that means that basically an original array can be formed, right? So if that's possible, an original array can be formed. If not, then original array cannot be formed. So which means that if you use just the commutative property of XOR, we can return the answer and we can find the answer, right? So we can just iterate through the derived array, XOR all the elements. If it is able to XOR and give a value of 0, then definitely an original array can be formed from it using all the values of derived, otherwise not, right? So that will be the approach. Let's quickly simply code this. It's very simple, right? Let's get to the coding part. So simple, I'll just create a variable XOR value and I'll iterate through the derived array, right? And XOR value will basically be XORed of all the values inside derived, and in the end I just return XOR val, and that would be the output, right? So let's run the code to see if everything is working fine, right? Oh yeah, I just need to check if it's equal to 0. That is the solution, right? That all the values inside the derived should be equal to 0. So that works. Cool, that's submitted. I hope you guys understood the problem. Thank you so much.